In our first chapter, we looked at simplifying expressions. We're going to be using a lot of those skills in this chapter as we are going about solving equations and also inequalities. Now remember, an equation has an equal sign in it, and we can actually work it out and find the value of x that makes it a true statement. So when you're looking at finding that value of x that makes it a true statement, it's often referred to as your solution, your root, your zero, or if you were graphing it, it would be your x-intercept. It's the value of x that makes it true, well, or whatever variable you're using, it doesn't have to be x. Solve means you're finding all the solutions that work, not just some, but all of them. Now, in certain types of problems, you're going to go ahead and correctly work out a problem, but you'll end up with an answer that does not work in your original problem, and that's referred to as an extraneous solution. Typically, you'll have an extraneous solution if you start out with a variable in the bottom of a fraction, or if you start out with a variable inside of a square root. Now, we need to go ahead and solve this. Well, to solve this, we want to get rid of the parentheses and combine like terms. So we could distribute through. Here we need to distribute through the -3. Then we can put our like terms together. 12 of the y's minus 3 of the y's. 18 plus 15. Now we want to get y on one side by itself, so I'm going to take the 33 to the other side by subtracting 33. Then I'll go ahead and divide by 9. Now, I would encourage you to leave your answer as a fraction because this one does not work out to be a nice, neat decimal. If it ended up being like 2.5, then you could leave it as a decimal. But if it doesn't work out to be a nice decimal, write it as an improper fraction. So here we have a rational equation. It's considered rational because you have variables in the bottom. You want to go about finding that least common denominator just like we did in the last chapter. So you want to factor all your denominators. And in this case, it's only the first one that really factors, but we can do the prime factorization of the last one. Once again, in finding your least common denominator, you write down all the different things that show up. Well, down below here, we end up having an x minus 3, just shows up in a couple spots. We happen to have a 3, happens to show up in a couple spots, and we have a 2. So we're going to write all those down. And if you had a choice, we don't in this case, if you had a choice in exponents, you'd always choose the higher exponent. So now we could do special forms of 1 just like we did in the last chapter to try to get each denominator to be our LCD. We could do that. It'll give you the same answer in the end. Being an equation, we could treat it a little bit differently. You know, if you do the exact same thing to both sides of an equation, it still remains a valid equation. So I'm going to multiply each fraction by my LCD. So I'll take my first fraction times my LCD, my second fraction times my LCD, and my fraction on the other side. So I multiplied everything on both sides by my least common denominator. Now at this point you will notice that here we have a y minus 3 on the top and the bottom. We also have a timesing by 3 top and bottom. Over here we have a y minus 3 times the top and the bottom. And here you have a 2 times a 3 top and bottom. So we could cross those out. They're special forms of 1, and then you could write what you have left. Well, here we just have a -5 and a 2. Here we just have a 4, 2 times 3. Over here, you just have a 5 times your parentheses. So, being an equation, we can do the same thing to both sides, and in this case, we're multiplying everything by your LCD. And if you multiply by the correct least common denominator, all your fractions, your denominators should drop out. Now it's just a nice normal equation. We have -10, and then we get 24, which gives us 14. Distribute through on the right-hand side. Now we can just solve it for x by adding 15 to both sides and then going ahead and dividing by 5. Now, this one doesn't end up being a bad decimal, but I still prefer the 29 over 5. Now, you would need to be concerned about what would cause the bottom to be 0. The only thing that would cause the bottom to be 0, if we go up here, would be if x was 3. Or if x was 3 over here. But we did not get 3 for your answer, so we know this answer works. If we did get x to be 3, that would be referred to as an extraneous solution. So we're going to do the same process here. We're going to go ahead and find your least common denominator. Well, this one doesn't have a denominator that's written, so it's assumed to be over 1. Same idea here. We only have one denominator, so therefore that has to be your LCD. You multiply each term on each side by your LCD. You'll notice over here you have a 2x plus 11 over a 2x plus 11. They're going to drop, leaving you that 6. So here we just have the black 5 times our LCD. Here we have our black 5 times our blue LCD. So all we have to do is distribute our 5 into our parentheses, distribute this 5 into our parentheses, bring down that 6, collect our like terms. We could subtract a 10x from both sides. We could subtract a 55 from both sides. Leaves us with a 6 on the left and a 0 on the right. Notice there's no variables left. 6 equals 0. Well, that's not a true statement. That's a false statement. So if you end up working it out and all your variables disappear and are canceled out and you end up with a false statement, then we'd write down no solution. Here we'll go ahead and find our LCD. The first thing you'd want to do is go ahead and factor all your denominators, and in this case the second denominator factors this here. Our LCD, once again, is all the different things that show up in the bottom, which would be our 3 and then our parentheses of a 5x plus 2. Multiply each fraction on each side by your LCD, so our first fraction times our LCD, our second fraction times our LCD, and then the right-hand side times our LCD. You'll notice here you have a 5x plus 2 top and bottom, so they're going to cancel out. Here you have a 5x plus 2 top and bottom, and you have a 3, so they're going to cancel out. And then over here, nothing cancels out. So over here, you're left with just a 12. Here you're left with the 3's dropping out also, just with a minus 12. And then over here, 0 times anything is still 0. On the left-hand side, you get 0. Right-hand side, you get 0. So in this case, once again, all the variables dropped out, but we ended up with a true statement. 0 does equal 0. If 0 equals 0, you're going to say it's a true statement, so it's going to be all real numbers. However, we did start out with a variable in the bottom. So everything would work here except what would cause the bottom to be 0. Well, if you go 5x plus 2 equals 0 and solve it for x by subtracting 2 and dividing by 5, that would give you negative 2/5. So it's really all real numbers except negative 2/5. So here you want to do find your LCD. Once again, to find your LCD, you want to factor all your denominators. The first two on the left side don't factor, but the right side is differences of squares. So your LCD is all the different things that show up, which happens to be just this. So we're going to multiply everything by our LCD on both sides. Our first fraction times our LCD, our second fraction times our LCD, and the right-hand side times our LCD. Then we can look to see if we have anything the same top and bottom. We have this top and bottom. They're going to drop out. We have this top and bottom, so it's going to drop out here. Both of these are the same top and bottom, so they're going to drop out here. So you'll notice all our denominators dropped out, and they should if you're doing it correctly. We're left with a 2 times our 2x minus 3. We're left with a 4 times our 2x plus 3. And here we're just left with a 5x plus 6. All we have to do is get rid of our parentheses, combine like terms, and solve it. Distribute through your 2, distribute through your positive 4. Nothing to do on the right side. Now we can combine our like terms. 4 of the x's plus 8 of the x's is 12 of the x's. Then we have negative 6 plus 12 is positive 6, equals to what we have on the other side. Subtract a 6 from both sides. We still have variables here. We still have to get x totally by itself, so we're going to divide by 7. 0 divided by 7 is 0. This answer would work because we don't have to be concerned about it causing our denominator to be 0. Because if you plug 0 in, 2 times 0 plus 3 is not 0. And 2 times 0 minus 3 is not 0. So it would work. So now an identity means every number in the domain is a solution. So basically, if you can show that both sides end up equaling each other, we know that this is an identity. So on the left-hand side here, all you'd have to do is just go ahead and FOIL. Multiply your first term of 3x times your 2x, your 3x times your 1. Then take our inner terms, negative 4 times our 2x, our negative 4 times our 1, and then bring down our 5x. Right-hand side, there's nothing we can do to it. We'll just bring that down. Left-hand side, we can go ahead and combine like terms. We have 3 of the x's minus 8 of the x's plus 5 of the x's. So they're going to cancel out, leaving us only with a 6x squared and a minus 4. That also happens to be exactly what we have on the right-hand side. Since we get the exact same thing on both sides, we know that this is an identity. So to show that it's an identity, show that both sides end up simplifying down to the exact same thing. We also have equivalent equations, meaning they have the exact same answer. They may look different, the work may be different to solve it, but if they have the exact same answer, they're considered equivalent. So this one has nothing to do to solve it, it's just x equals 9. Now over here, they'll be equivalent if we get the exact same answer out of this. Well, on the left-hand side, we have a fraction equaling a fraction. They both have the same denominator. Well, the only way that can be true is if the tops are both equal. So we can set the tops equal. Solve it, we get x to be 9. So since we got x to be 9 for both of them, these are considered to be equivalent equations. Now, this is referred to as a literal equation because it's going to have more than one variable in it, which isn't bad, but it's very similar to solving this problem here. If I gave you 5 is equal to 2 times r, you guys know you just go ahead and divide by what r was being multiplied by. And you can see as we look at this top problem, we actually have r being multiplied by something. So to solve it for r, you got to divide both sides by that 2r. Over here, we got to solve the top one for r. Well, consider this one. Suppose you had a 7 is equal to a 12 plus 12r. Well, you guys know that you'd have to get rid of this plus 12 here by subtracting a 12 from both sides. And then you'd have to get rid of timesing by 12. So you divide both sides by that. So what you see at the top is here we have r being multiplied by something just like you had here. Then we were adding something that didn't have r's, setting it equal to something that didn't have r's. So what we have up here is very similar to what this is. So our process in solving it is going to be pretty much the same. So we got rid of the thing that didn't have r's. So we're going to do that here, get rid of the thing that doesn't have r's. So we're going to subtract that p from both sides. Now you can see that you just have r being multiplied by something. So to undo multiplication, you should know you just have to divide. And then we have one more problem here. We need to solve it for h. Well, to solve it for h, we could go ahead and distribute through the 2. We would not have to. By the way, this is an L times a W. It's not a 1W. So if we distribute through, now we're trying to solve it for h. H shows up here, H shows up here. This has no H's, so we want to take that to the other side. So I'll subtract a 2LW from both sides. Now, we, on the right-hand side, cannot combine these together because they're not like terms. We don't have the same variables here. The first one is in HW, the second one is in HL. However, H that we're trying to solve for is a common factor. So on the right-hand side, we could pull an H out. And why would we want to do that? Well, on the right-hand side, we now have it as H times something. Well, to get H by itself, you should know to undo multiplication. You just have to divide both sides by your parentheses.